This is the screencast for section 7.1, example 6. Again, we're going to find a cumulative total of something using integration. This one says a pump connected to a generator operates at a varying rate. So it's not a constant rate of change, depending on how much power is being drawn from the generator to operate other machinery. So if the other machine is turned on, this generator is probably going to pump less. The rate, gallons per minute, at which the pump operates is recorded at 5-minute intervals for 1 hour, shown in this table. We want to know how many gallons were pumped during that hour. Okay, so we don't have an equation this time, so we can't just integrate. In this case, we're going to have to estimate integration using one of our methods. Now we've got RRAM, MRAM, LRAM, we've got trapezoidal rule, so we're going to use, this is data points, which you don't have to type them into your calculator every time. I mean, they're generally going to create a picture of something like this. So each of these data points is going to provide the end of a base of the trapezoid. So I'm going to use the trapezoidal rule to best estimate this data. I'm going to calculate the approximate area under this velocity curve with the data by using the trapezoidal rule. And remember, there's about a million ways to do that. So first you can calculate each trapezoid independently. So each one is going to have a width of 5, and then the first base is going to be 58 tall, the second base would be 60 tall. Then the next one, still a width of 5, so 5 seconds, but then the second base is going to be 60 tall, and then the third base is going to be 65 tall. And then the third trapezoid will go with 65 tall and 64 tall for the bases, still a width of 5, and basically you're going to continue that pattern all the way till you get to the last trapezoid whose bases are both 63. Or you could factor out the 5 halves, because each of these is being divided by 2 and multiplied by 5 because they all have the same width, and we get the first base used once, all of the middle bases used twice, and the last base used once. Or to make this easier for our calculator, we can say 5 halves, parentheses 58 plus, and then go with 2 times all the middle ones, close your parentheses, and that adds 63. Or if you didn't factor out the 1/2, you can take 5 and factor that out and leave the 1/2 in, and then each of these is used once in the middle, and then 1/2 of the last base as well. Any one of these is perfectly acceptable. You only need to show one of them. As long as you write your string out for trapezoidal rule, you have got enough information to provide your grader with how you got this approximation. Now this equals 3,582.5 gallons. However, that is an approximate value for how many total gallons were pumped. So it's approximately 3,582.5 gallons. Now try problem number 27. It says a machine fills milk cartons with milk at an approximately constant rate, but backs up along the assembly line, cause some variation. So the rates in the cases per hour are recorded in hourly intervals during a 10-hour period from 8 a.m. to 6 p.m. So I know this looks weird. It looks like, well, Ms. Larson, why'd you copy the table wrong? Shouldn't it start with 1 and end with 12? Well, because we started at 8 a.m. and went through to 6 p.m. So each width of each of these trapezoids is still going to be 1, and then these are going to be the heights of your bases. Now I'm going to pick 1/2 times the first base, and then 1/2 times the last base, and then individuals of all the middle ones. The trapezoids all have a width of 1, so technically there's a 1 on the outside here. And I get that there's about 1,156.5 cases of milk cartons full.